You're listening to Let's Talk AI.
Okay, so welcome to Let's Talk AI. Today's guest is Ali Ayub. Welcome, Ali.
Thank you. Thank you for inviting me to the workshop. Oh, sorry, podcast.
No worries. Glad you could be here today. So Ali's focus is assistive robots. But, who is Ali? Ali's background here for us. Ali's a postdoctoral fellow here in the SIRRL lab at the University of Waterloo. Ali, maybe you could tell us a little bit further, how did this all start for you? AI, everyone seems to be into it today, but obviously you got going some years ago. So how did it all start?
hmm Yeah, of course. Well, for me, I think it started during my undergraduate studies, and that was back in Pakistan. So I'm originally from there. And it actually started with like a small course, and we were working on like a small robot, designed it, the algorithm for like a line following kind of very simple. But that really got me going um, into like AI and robotics. And then I think after that, I just focused my courses around that. Went for my master's and Ph.D. At Penn State. Yeah, towards and focusing on AI and then obviously I'm here now.
And how long have you been here at
So
University of Waterloo?
actually I graduated from my PhD in May 2021, and I joined here in July 2021. Right after that, yeah, I got a
Oh,
small break.
okay. So this is really recent. Recent you've joined our team here. So this high
Yes, yeah,
level category, assistive robots. What's that? What's that title mean? What's that all about?
yeah. So assistive, or I would start maybe with the assistive technology in general, is just any kind of technology machine that can help complete or any kind of tasks for people maybe that might have disabilities or older adults in general with like tasks of daily living. That's like I would say is like a very high level definition of assistive technology. And if you add a robot in that, then well, the robot will be doing that particular task. Um, and as an example, it can go from say I don't know, like someone who maybe have like a very assistive kind of wheelchair, which can drive you around in a more socially acceptable way. Or it could also be like a household robot that maybe set up a table for your breakfast or cleans the table after you're done with your breakfast tasks and stuff like that, which is what I am interested in, the second part. So
Okay,
yeah.
well that gives a little better focus here. I mean, we've seen way too many Hollywood movies with evil AI robots. So, um, maybe that term there, robot. How broader is it now than we would perceive from the past?
Oh, that term right now is just extremely broad. Like even like there are robots that can start from like small, very very small robots to like big industrial size robots that can even operate outside in the wild and stuff like that. So the term robot has, I would say, has adapted a lot, and the ones that we see in the movies that might be very 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 specific and probably not well possible right now either. Um, yeah. But yeah, I mean, I would say like the ones in the movies that people have the perception they're evil and everything. Well, at least our lab and me, we don't work on that. We're working on assistive robots that can help.
Okay,
So
okay. So
yeah,
you talk
yeah.
about your lab, the SIRRL lab. What's that lab about? And then
Yes,
we're gonna dig down deeper and find out your role in that lab.
of course, yeah. So SIRRL, it's actually a social and intelligence robotics research lab. So as the name says, it's the research will be about intelligent algorithms and obviously the social aspect of that. So the lab kind of works on the algorithm design, maybe AI, maybe ML side of it, some of it sometimes. Um, but the algorithms are designed not in isolation of, say, humans, but for the applications. so that these can be applied on robots that will operate around us and for us. So, for example, applications like helping people with dementia, or in this case, like older adults in their households. So those are like some main areas in the lab, focusing on older adults, specifically helping them in like assistive home kind of scenarios, and like I said, people with dementia, in particular children with dementia. So those are, like I said, two big areas in the lab. Yeah, and then there are small other.
You talk about assistive help. Is this something to help them get out of help them to get out of a chair or get out of bed, or help them feed themselves? Or give us some idea. What does that mean, assistive, though? Like, what are they assisting with?
Yeah. So for example, the help with, say, children with dementia, that's mostly social aspect of that. That's mostly sometimes is a conversation, perhaps even helping them do particular tasks, but usually through like social interactions. And there are multiple postdocs and like some Ph.D. students working on that. But on the older adult side, where it's about helping the older adults in their households, that can now vary depending on a social interaction where the robot can just simply interact with them, and help them, perhaps by just talking to them, interacting with them, maybe suggesting some things, or like an intervention could be the case, or actually physically performing the tasks. So for example, just like it mentioned before, like tasks of daily living. Oh, let's just clean up this table for you. Let's just set up tables for breakfast. Let us fetch you a object that you're interested in. I don't know. I'm sitting on the couch and I'm like, oh, can you bring me some? I don't know. Like, can you set up the table in front of me for coffee or something, or cereal? And sure, the robot will go get a cereal, get a milk and bowl and spoon, and yeah. So that's like, you're designing an AI algorithm that understands all of these things, that can actually reason on that, and then obviously be able to help the human in the household, which is like an older adult in this scenario. So, yeah.
So it sounds like these are voice activated type interactions.
Well, yes, many of the robots that we work with, there are voice activated interactions. But there also can be through like a graphical user interface. So it can be either or, depending on the application as well. And also, generally, it's easier to actually do GUI-based interactions than the voice-based, because it's just because there can be a lot of errors in that. Yeah, yeah. So particularly, I actually focus more on the GUI-based interactions.
Okay, so let's get the spotlight on yourself here. So you're part of this SIRRL, the SIRRL lab. I think you said previously there's about 20 researchers in the lab there.
Yes.
What is your role? What are you doing specifically? We put the spotlight on Ali here.
Yes, of course. Well, so like I said, I'm one of the postdocs there. There are actually right now there are 5 postdocs in the lab, and my role in the lab is more of as a researcher, particularly so conducting original research, and then mentoring some master and PhD students as well. So currently I'm mentoring like 2 master students in the lab and 1 PhD student with their research. That also is related to my main area of focus as well. So that's currently the role that I have in the lab.
And your focus is what?
So my focus particularly is like, as a broad term, is assistive robots. And if you want to go further down, that would be household assistive robots. And within that, it would be about actually long-term deployment of these household assistive robots. And for that particular scenario, for long-term deployment, I work towards lifelong learning algorithms or computational architectures that can allow these robots that are going to operate in our homes to be able to adapt to our needs and our preferences and our environments over time, because, well, all of these things are going to change. My needs can change, my preferences can change, and obviously my environment itself could change over time. So that's really the main focus of my research. Yeah.
So when you say lifelong learning, is that for the robot or for the person?
For the robot, yeah, for the robot, because for the robot is supposed to assist, for example, like I said before, making breakfast. So say I start with, you know what, I like cereal today, and perhaps the robot knows how to do that, but later, after, I don't know, a month, I just get bored with that. I want to change the cereal, or maybe I can completely change the breakfast itself. So now the robot has to adapt and be able to understand, okay, well, what is the new thing? And that's really what I focus on, that the robot can learn from the human by interacting with the human for the human.
Okay, so I'm going to guess your lab, you talked about dementia for seniors and things, dementia for infants and children, or children, I guess. How do you actually test that? You're not bringing them into the lab, I'm guessing. Do you take these out to their place or their facilities?
Yes, so they obviously don't come to the lab. A lot of the times, we actually generally have like interactions with hospitals or with other care centers, and usually we collaborate with them so that we can work towards some kind of a solution that can where the robot can interact with the person. All during, like, for example, COVID time, we were not able to go there, so it was mostly online. Somehow it was like all the interaction was happening online, but yeah, in general it would be through coordination with those institutes. For example, like for the older adult case, I think we do collaborate with the Aging Institute at Waterloo, research at aging. Yeah. So yeah. So like that's generally how we focus on that. Collaborating or coordinating with these care homes or institutes. Yeah.
Okay, so paint for us, get out your sketch pad here and paint for us a picture of the future. Would there be one of these in every home, one per person in every home, one for a family? Like what do you think it's going to look like?
So for example,
we're all going to have our own little R2
R2D2.
We're going to have our own little R2D2 running around the house.
Well, that would be perfect. Actually, so I think I mean, the robot will probably be, it can be more, it can be like a multi-agent problem, like there can be multiple robots in the house, depending on the applications. But I think if there is one personalized robot that can do pretty much the task that I need to do, then I believe it will just be one robot in the household that can hopefully perform most of the tasks. So like an embodied structure that can move around in the household, that can actually manipulate the, say, things in the house. So I don't know, pick objects, place objects, move things around a little bit, clean. If the robot has all these capabilities, then I think it'll just be one. But looking at there are so many other different kind of smaller robots, it could be like a fleet of one big robot guiding smaller ones with that. Yeah, so that, I think that is actually a very viable future as well, where there's like a main robot that is more personalized, that can interact with the human, and then maybe others, like a Roomba, for example, could be there, and the main robot could actually guide it, like, don't just roam around in the house, go and clean this particular area. Yeah.
Yeah. Okay. So you did talk about the facilities for the aged and things like that. Would you see these in seniors' homes, like a caregiver, one robot that services X number of people, or what's that scenario going to look like?
I believe we are focusing more towards each person particularly. So like each person has their own robot. So like maybe in their homes. Now, it is possible to work towards robots that can perhaps work with multiple people. And like I said, that's actually would be one challenge of my research, my grand research agenda would be that, like, to the lifelong learning problem so that it can further adapt to multiple users rather than a single user. Um, but but that I would say is like that would be a much harder problem than just one home and one person. Yeah.
Well, no, you mentioned the scenario of bring me cereal or bring me coffee or something, but we all have our specific ways we like our coffee. So,
Yes.
User A may like it with cream, and the other one wants it no cream with sugar or
Yes.
something.
Yes.
So,
Exactly.
how difficult is it for it to learn these behaviors?
So currently, um, one of the difficulties, I can start with that. One of the difficulties is first of all, how can the robot sense? So which means using, well, mostly it is from the camera. So how can the robot first of all, using its camera, detect all of these objects correctly? Now that's a very difficult task on its own, and a lot of the times it can either miss the objects within wherever they are, and it can either misclassify them. So that would be pretty disastrous when the robot thinks a book is a cereal. And I've seen that happen in one of my in one of my projects. It actually happened, or it said cereal is a book, and I was like, okay, well, I'm so that is like one of the big difficulties already from the sensing point of view. And once you have sensed correctly, then it starts towards, okay, now how can I encode this information and then be able to, I guess, learn something useful out of that, to be able to understand the relationship of, say, for example, a cereal with a breakfast. So as an example, I always start with this as like I always explain this scenario of, say, picking up or making a breakfast kind of scenario is like, okay, the robot first has to understand the objects, which is the cereal. Then it has to understand where can it find the cereal. Okay, perhaps in the kitchen. Where in the kitchen it can find the cereal. Okay, perhaps on the table. And then it has to understand, okay, how can I navigate to the kitchen? And then from there it has to navigate it back, bring it to the person. And that's all happening still for just one particular task. And then it's just like, and then the interesting part then becomes is like, once we make it a lifelong learning problem, which means now the robot has to be able to adapt while not forgetting the previously learned knowledge, which is a very difficult problem. Actually, we in machine learning we actually get to this problem called catastrophic forgetting, where if you train machine learning models with new data or new objects in this case, it will just forget the previously learned knowledge. And that's a very, very...
What does that mean? I've never heard that term. How can a model forget something?
Exactly, because like, so the model is actually learning most of your information in terms of some parameters, weights, if you want to go in more technical. And once you make the model learn new knowledge, it changes its weights so that it can, and once it changes weights, yes,
most of the more recent data is more important.
Yeah, it just gets biased completely towards new data or new knowledge, and it just forgets everything from before. So that's a challenging problem already in lifelong learning itself. So like I said, I just gave you a bunch of problems that can happen within this, and obviously, finally, the challenge is also just manipulating the objects. Like, okay, how can I accurately grasp an object, navigate to the right place, and place it?
So you pick on cereal. Say cereal was sitting on the counter, and most cereals have pretty good artwork on the front of them. And it sees the picture of cereal, which is an image of cereal, but it's not cereal. It's cardboard with glossy colors on it. How does the robot know the difference between a bowl of cereal and a picture of a bowl of cereal?
That exactly, like I said. So if the bowl is filled with cereal and if the bowl is empty, the robot can find that using. There are some state-of-the-art computer vision techniques now that you can use perhaps to train some particular kind of model, machine learning model that can perhaps detect that. However, if you have one type of cereal which doesn't look that different from another type of cereal in two different bowls, then good luck. Or like I said, like a box of cereal, it can be easily be a book.
So if you've got AI tools in your tool belt, if you want to call them that, it's give us a rundown here. You've got computer vision, natural language processing. What are those tools that are in your tool belt to do this task?
Oh, perfect. Yes. So currently, for the computational architecture that I'm designing, so the tools that I need, or I guess I have to use, is first computer vision, some machine learning tools. I actually do use cognitive science, or in term neuroscience. I try to design my models for any kind of computational model through inspiration from cognitive science theories of learning and memory encoding. So that, and then human-robot interaction, and finally the control theory to actually manipulate and move around. So that's a lot of things.
And the NLP as well, the natural language, like the talk.
NLP as well, although I don't really focus on that much, but yes, if you will need that, yes, yeah.
And
if
right
you
now
have to interact with the robot. Yeah.
And right now, I'm guessing all of this is done in English.
Of course, yeah. I mean, if I want to move on to something else, that would make another problem on top of that.
Right.
Yeah.
Okay, so lots of opportunities ahead here. It looks like for research and development and growth.
Oh yeah, like I said, it's like all these areas that I mentioned, people obviously can work on any of these, and mostly our lab focuses on more so on the AI part. So maybe designing the AI algorithm, not so much on the computer vision or even ML, like pure ML research, but rather using those techniques for developing those computational architectures and the human-robot interaction side. So that's where the lab will be in most of my research as well.
Excellent. Well, this has been a real eye-opener for me today. I'm want to thank you again for joining us today, and let's talk AI. Maybe a chance to talk to some of your other colleagues in your lab and learn even more about assistive robots. Again, thank you so much.
Yeah, thank you for inviting me. It was actually a great talk. Yeah.
Okay, awesome. Have a great day then.
Yeah, you too. Bye.
Bye.